So here's been one of the interesting challenges in the last couple of days. I just learned that the newer version of Java has problems with what I'm showing you here. So this package here is Logisim. And Logisim was used, well, is what we typically use to simulate logic operations, AND gates, OR gates, exclusive OR, and when you can put these AND gates, OR gates together to build a computer, to build a CPU, to build something that can do addition, and to build a register in our case. So the more common way of representing an AND gate, the more common way of representing an AND gate is to use this type of diagram or schematic diagram. And this is the more common OR. And then this one here is the NOT gate or the inversion. So these are, if you look at the AND gate, if I have two voltages or two inputs going into them, I have 0, 0. I only have 4 different combinations that I can bring into this OR gate, X and Y. So if I bring in a 0, 0, for all of these, there's a script, I suppose, that's often helpful. With the AND gate, the script is the output will be true if both inputs are true. And that's the only time. So the output for the AND gate will be true, and I'll use an X and it. Since I'm running out of space here, I'll just use a dot, kind of a multiplication symbol, X and Y. So the output will be true only if both are true. So it is the logic of AND that you should have seen in Math 130 or the program, the introduction to programming prior to this class. We can do AND gates, we implement AND gates with hardware. The OR gate should have familiar logic to you as well. For the OR gate, I'm going to use this symbol here. It's common to use what looks like a plus sign for OR, and 0, 0, 0, 1, 1, 0, 1, 1. What are all of the combinations for this truth table? Well, so the kind of the script for the OR gate is that the output will be true if either one of those is true. So it won't be true here, and it says it's an OR gate. So it says, is either X or Y true? Question mark. And the answer is yes. One of them is true. One of them is true. At least one of them is true. So that's the output that we're expecting for the OR gate. A little bit later, we'll see another OR gate that looks like this. So the standard OR gate diagram, but it has this extra kind of bar here. And then this one is exclusive OR. So let me just put an XOR. So this is the exclusive OR. And what it says is that given X and a Y and the same combinations, the output will be true if only, so I'll do an OR, but I'll put a circle around it. That's a common. That's one way of showing an exclusive OR. So exclusively one of them. So this looks largely like the OR gate, except for the one output here. So it means that exclusively one of the inputs is a 1. So whereas the OR gate just says, do we have at least one of those showing up as a 1? And then finally, the inversion is only a single input. So I don't need an X and a Y. So it has an input and then it has a particular output. And so whatever I put in there, the output will end up being the opposite. So if I put in a 1, I get a 0, and then it's going to be hard to see. And if I put in a 0, so a 0 gives me a 1 gives me a 0. So it just negates. A 0 becomes a 1, and a 1 becomes a 0. So those are the fundamental gates. Using these three, those bottom three, the and, the or, and the inversion, you can build memory. You can build registers. So these I'm used to kind of working with for the last 10 years. What happened recently is that when I update it, and possibly when you've updated, when you update your version of Java, Logisim has not been, the original Logisim, the one that's even posted on our shared drive, hasn't been updated probably in 11 years. So there are other institutions that are doing branches of Logisim, and they want to extend it. So there are thousands of students and hundreds of, or at least many institutions that are still using Logisim because I think it's a wonderful teaching tool. And I've heard a number of students say, you know what, Logisim is actually really easy, and I've been able to take this into when I've transferred over to San Diego State or elsewhere. So it is a useful tool, and I know that some will get great benefit out of it. The challenge is that it's, one of the things with this new version of Logisim, the one that I'm looking at now is Logisim Evolution, is that instead of these gates, now it's using these gates over here where it's a simple box with an and sign. So the ampersand is what it actually is. This ampersand sign, the and sign, is equivalent to what we see off to the right with the and. The or sign, I think, is interesting. It's rare to see this, but there's this greater than or equal to 1. At least for me, I'm not used to seeing the or represented with a greater than or equal to 1. So one way of thinking about this or is that this output will be a 1 here if the sum of those two inputs is greater than or equal to 1. So if we go back here and look at the OR gate, if I were to add 0 and 0, 0 and 1, I don't get an output that's greater than or equal to 1 until the bottom 1. So this will be true if the sum of the two bits is 1 or more. So actually, well, I think, 0 plus 1 is going to give me a 1. So it has to be this greater than, it's actually greater, it's when the sum is greater than or equal to 1. So that's not quite the logic here. The greater than or equal to still strikes me as strange, but it's doing the OR function. And the greater than or equal to 1, I can't see, it's not the sum of those. So I'm not sure what the thinking is between the greater than or equal to sign, but it is giving us the OR function. So it's not just simply adding the two together and outputting the truth of that, but when this value is, when the two together are both 1, then you'll get an output of 1. And then the inversion down here operates in the standard inversion. Now, what can you do with this information? So before I do anything else, just to say a quick couple of words more. I think there was a question about the exclusive OR. The exclusive OR, don't forget, whenever you have two inputs, I'll just write this again to answer a question that came up in the chat box. If I go through this and I have two inputs, if I'm going to take those two inputs and perform a so-called exclusive OR operation, what I'm asking myself in the sentence I suppose that I would write with an exclusive OR, the question is, Is it true that only one of these is a 1? And the answer here would be a no. And you'll answer a no with a 0. You'll answer a yes with the 1 or a true with the 1. So this is a so-called exclusive OR. Is it true that exclusively one of these is a 1? Sure. Is it true that exclusively one of these guys is a 1? The answer is yes. Is it true that exclusively one of these is a 1? The answer is no. So an exclusive OR means that there's only a single one of the two and not both of them. So an exclusive OR says exclusively one of those 2 bits is a 1. A regular OR says, do I have a 1 anywhere? And as long as you have a 1 in there, he's true. So that's the big difference. And so they really differ in that last, let's see if I can highlight this. They really differ in that last column or the last row. So that's the big difference between those two. Questions or thoughts on that? I hope that helps some. So if I were in your shoes, I would certainly write down all the combinations, and then I would also write a single sentence script that helps me kind of answer what the output would be. Is it true that exclusively one of the inputs is 1? Is it true that at least one of the inputs is a 1, and so forth? Good, good, good. I see the question. I think it looks like it was answered. So that's exclusive OR. The other thing that's going to be really useful for us, and I'll just kind of allude to this now a little bit. Notice that with the exclusive OR, I think I mentioned it last session, if you were to do an addition, 0 plus 0 is a 0. 0 plus 1 is a 1. 1 plus 0 is a 1. And a 1 plus 1 is actually a 2. So this almost gets us there. It has kind of if you're looking at adding those two values, 0 and 0 is 0. 0 and 1 is a 1. 1 and 0 is a 1. And then 1 and 1 is a 2. So if I were to use 2 bits to represent the sum, exclusive OR captures the least significant bit information perfectly. So you'll see a bit later that we can use exclusive OR at least for a part of, to do part of our addition. So exclusive OR is it's incredibly useful. And when we're doing addition, it captures part of what we want to capture when we do addition. I also mentioned that if we're using 2 bits to capture the addition of 2 bits, although exclusive OR captures the least significant bit, I mentioned that we would need something else to capture this information here, and it turns out that the 0001, 3 zeros and a 1, works over here. So in order to do addition of 2 bits, we're going to use an exclusive OR, but we're also going to use an AND gate. Those two together give us an adder. Those two together help us capture the information that's necessary to do the addition of 2 bits. More on that later, but that's something to kind of think about. So Logisim evolution looks a bit different from this. It will have not this OR gate here, but you're going to see in Logisim evolution an OR gate that looks like this, and you're going to see an inverter that looks like this. And so we can build the same circuit that we see here using different gate symbols. So let's talk about what we're looking at, and then let's maybe do a demo in Logisim. Bottom left has plus and minus on these magnifying glasses to allow us to zoom in or zoom out. And it also has either a finger or a cursor. If I have the cursor, I can kind of manipulate, grab, select different elements. The gates that are available to us in Logisim are seen here. So if I want to put in a NOT gate, if I want to put in an AND gate, or exclusive OR, so I can put these gates before I kind of talk about what we're seeing here at the top. This here is our RS flip-flop. Everything that we're seeing here. Let me take just a quick second to show you some of the basic functionality of Logisim. I'm going to go back and select the cursor, and I want to put inputs in to see if this AND gate does what I think it's supposed to do. Notice that this AND gate shows up over here off to the left. When I click this one here, the OR gate. So as I change elements, I will end up getting 4 corners that have 4 squares. 4 squares meaning that this is now selected. If I select this output pin, this pin here, it shows up as tilde-Q. And if I select this one, it shows up as S. Each one of those, every single one of these will have a different set of state variables. So you can see these state variables for the AND gate. For example, this says facing, the number of data bits, the gate size, number of inputs. So this is facing east because this little red dot is going eastward. If I tell it that I want to face south because it fits better in my circuit, then I will get it facing downward. Or if I tell it that I want it to face west, it does this. It's facing west. Oddly enough, with this new version, it's kind of upside down when you tell it to face west. But as a simple AND gate, this works. If I go to a label, if I want to remember what this is, if I want to put a label in it, it puts a string or some name inside of this. So I get an AND gate for that one. If I go to the instance variable for this one here, my OR gate, it doesn't say that it's an OR, but I will make it an OR by, I'll put a label on there and hit enter, and it stores it as an OR. So those are kind of instance variables. It gives you some information that you can control on this object. So this is an AND gate or an object. So let's spend 60 seconds testing it. I want an input. Well, none of these look like inputs under gates, but under wiring, I can put a pin here and then draw in. Control C, Control V normally would work, but that's different on this version of Logisim. So this is pretty good. Now I have 2 inputs. So I put a 0 and a 0, or a 1 and a 1, I get a 1. 1 and it with 1, give me a 1. And that's highlighted by green. A 1 and it with 0 gives me a 0. That's a darker green. Now, it would be good to put a pin here. So what I'm going to do is grab a pin. And this is an input. So I'm going to change it from an input to an output by changing one of its so-called, I'll think of these as instance variables. And when you change it to an output, it goes into an O or a circle. So when you see a circle, I tend to think of O for output. So now, if I turn this from facing east to facing west, you'll see that there's a little dot right here that lights up. Let's get this out of the way. Let's select all of this. And so now I have an AND gate And I'm going to choose this poker here, where I can now use the poker to change these values. 0 and it with 0, 1 and it with 1. The cursor won't allow me to change those values, but the poker will allow me to make those changes. So those are kind of the basics of Logisim.